let us get started. Um, he helps startups and businesses build web application and tools and also assist them on their journey to digital transformation. I've personally worked with Sugam and he has great spirit and even a bigger contagious laugh. Let's welcome him on the speaking platform to talk everything about Beyond 12 Factor app in cloud native application. Welcome, Sugam.
Thank you, Kritika. So let me share my screen. Share screen. You should be able to see my screen now. All right. So let's get started. Hello, everyone. Welcome to Syntax 2021. I'll be talking about Beyond 12-Factor app in cloud native applications. So before jumping into the talk, let me introduce myself. I am Sugam Shakya, and I am a senior software engineer at Leapfrog, and I've been working in software industry for around like 5 years now, and I help startups and businesses to build their products and services, and yeah, that's all what I do. So without further ado, let's move on with the talk. So today we'll be talking about 15 different guiding principles that are provided by 12-factor app, and there are a few more that I've added there. So we'll be discussing about why following these guidelines will help us to build cloud native applications and help us to like scale our app horizontally and make our life easier. So let's get started. So the first principle states that one code base, one application. And so the basic principle here is that there should be one code base that is tracked and revision control and with many deploys. So what that means is we might have one app. We should have one app in one code base. So so how do we define an app? So an app should be anything that's cohesive and that differs from context to context. So a front-end app could be one app in one project, but that same front-end could be divided into different apps based on the product or the organization structure. So app could be anything based on the context. So how we can violate this principle and how it like makes our life difficult is that we can have one app in like multiple code bases. So when in such scenarios, what happens is in order to deploy that app, we'll have to pull, we'll have to like pull in different pieces of the code from different repositories, and it would be like automate for us to build the artifact and then deploy it to different environments, right? So other violation could be like we could have different kinds of app, like they are less cohesive into one code base repository, and that could be, for example, we could have a front end and a back end, and if we have like ETL pipelines in our app, then having that code also in the same repository could also mean the violation of this principle. So what about the shared data that we have? The shared data like should be residing in the different repository, but that does not mean that it's a like whole new app. That should be since it's a dependency, we should vendor that dependency as a shared package inside the code base of other app, right? So this will help us to not step in each other's shoes and work parallelly in different teams. And moving on to the next point, so we have to be like API first when building cloud native applications. And why is that? So there could be different teams working in the same product or building like same sets of services. So when we are building a whole new product, let's say, for example, we are building an e-commerce application, there could be like different services and different team members working on different sections of the app. And in the end, we'll have to provide a very consistent experience to the user. So we'll have to integrate different services in the end. And if we go API first, what we'll do is first create the edges, or let's say first create the public contracts, or let's create API designs and finalize it first. And what that will help us do is like we'll just define a public contract, and no team will violate that public contract in the future. So that helps us to work, helps different team members to work parallelly, and it enhances collaboration with teams. And uh, so that's another benefit that we have in API first design. And it also helps to bring API consistency. So when we go API first, we'll have a whole set of API management lifecycle to finalize the API before we even start working on it. And that brings a lot of collaborations, and ultimately the result would be a high consistency of API. If API is what our business like provides service for, that's something that we need to look into. So we can use different tools like Swagger, Postman, Apiary to help us work with API first. And if possible, we should follow open API specification, since following this specification helps us to standardize our APIs, and it would be compatible for others consuming other services. So the next point is dependency management. So what it states is we need to explicitly declare and isolate dependencies. So most of the framework, or most of the so the pattern or trend that we follow these days are like follows this principle. So when we build a Node application, or a React app, or Angular app, we explicitly declare our dependencies in package JSON. So that means we'll declare all the dependencies that our app relies in, including the versions. So that's very important to declare the version as well. And we'll not have any central dependency that our app will depend in. So when we install all the dependencies, we'll have a separate space where all our dependencies will reside, and it will not be mixed up with the code that we have for our like core application. So what's the benefit of having a dependency, like declaring dependency? So what it helps is, for example, if we have to add a dependency using a curl command in our terminal, and it works, all the functionality that we are working actually works on our machine. And what if we have to deploy that to the cloud environment? Uh, so in that case, we'll not like ship our machine or ship our laptop to the clients, because it's a cloud app. So in that case, our app would fail in the production environment. So it's very important for us to manage the dependency explicitly. And also we'll look why this is important in the upcoming slides. So let's move on to the next one, and that is design, build, release, and run. So uh, originally it had build, release, and run. What this means is that we need to have different stages for different we need to have different stages, like while deploying an application. So build, release, and run. So even before that, we need to design how our build pipeline would look like, or how our dependency are going to be get bundled. So whenever there is a new feature, we'll have something to design. We need to like look into the dependencies and what needs to get added, what needs to get removed. And after that planning is done, we write code. And then when it's time to deploy, we build our application. We build our code base along with all our dependencies into a build artifact. So that could be a Docker image as well. So that build should be uh, that build should be pure enough so that it could be deployed to multiple environments. So only when the build is now pushed to the environment, along with when the build is pushed the cloud environment, the configurations and credentials will get injected to it, and that will create a release. And that release should be tagged uniquely with a unique identifier, so that if there are any issues in the environment, or let's say if there are any issues after the deployment, we can like easily roll back to the previous tag or previous release. And the run stage is what the cloud native the cloud environment, or let's say the cloud services will do on our behalf. For example, when there are like new instances to spin out, we just let the cloud service know that this is the image or this is the build artifact that you need to use, and that's all. And it's the responsibility of the cloud. It will take that artifact, and then it will run your application in the cloud environment with all the configurations necessary injected in the environment itself. So all these processes should be done with CI/CD pipelines and not manually, because doing manual all these steps performed manually is a hectic process. And since we aim to achieve continuous delivery or continuous deployment, ultimately doing that would hinder our continuous delivery goal. So we'll talk more about that in future slides. So let's move on to the next one, next guiding principle, and that's config, credentials, and code. So we need to make sure that our app stores, or let's say externalize all the configs and credentials and not store them in the code itself. So the guiding principle is that we should store config in the environment and not anywhere else, not in the properties file, not anywhere. So the from the high level, how we should think is that we should treat our app like it's open source, and and if we decide to open our application or application code base to the public user, would we be exposing any sensitive information that would jeopardize our business? So that should be our litmus test. So externalizing all the config and credentials also helps to make our build pure. So that means if we have to deploy the same build into a different environment, we need not go back to the code, change some URLs, and then generate another build artifact and then deploy to that particular environment. So it also prevents us to scale our app in the cloud environment, and also help us to maintain the dev prod environment parity. So different tools could be used in order to like inject these configs and credentials in the environment itself. So first off, the cloud service provider would provide this service. For example, the secrets manager or parameter store provided by AWS are the tools that helps us to achieve this goal. And also there are like third-party tools like Vault, which will help us to externalize all these configurations. Like moving on, the next guiding principle is treating logs as streams. So when we are building a cloud native applications, we should never treat logs, or let's say we should not be focusing more around how we are routing logs, where we are like storing the logs. And instead, we should only treat logs as event streams, and only, or maybe like only writing the logs in standard error or standard output. So the reason behind that is that in the cloud environment, the instance where we deploy our app are only like lives for a few minutes or few hours, and it's not sure that it would live as long as necessary, because we are focused around horizontally scaling our app, meaning like instances could be up and down based on the load, based on various other metrics, right? So if we treat logs like that, we will have to do a lot of things that are quite an overhead for us. So we should instead focus on the core business value that we provide, and only focus on the core application, and let the cloud service providers take care of the rest. For example, like log aggregation or log rotation. So all the overheads that comes with the logs. But if we need to anonymize our logs, we can just emit an event, and dedicated service would only do some like minimal stuff, and the rest would be taken care by the cloud service provider or any third party service, for example, like ELK stack. So the guiding principle here is that we should not treat we should not like overkill with logs. We should only focus, we should not only take them as event streams. And the next one is the disposability, and this is very important in order to build a very robust system. So the principle here is that we need to maximize robustness with fast startup and graceful shutdown. And what this means is that when we build our cloud native application, we need to make sure that our app starts quickly. And when it gets killed, or let's say when it's about to shut down, it needs to shut down very gracefully. And why is that? So the reason behind that is we'll also talk about this in the future slides, but we'll have, like serverless architecture is in the run. So for example, if our app is deployed in Fargate, there will be like instances or services up and running based on various metrics that we set up there. So what if what if there is a spike of API requests in our application, and our app takes more than 5 to 10 minutes to actually start up and serve the APIs. So from the business perspective, what it means is like losing users, right? So nobody wants to use the application which is like down most of the time or when it's needed. So when there is a spike of API requests, we need to make sure that our app is like swift enough or quick enough to serve as soon as possible. And there's also a reason why you need to shut down gracefully, because there are resources that are being used by our application, and when we do not shut down gracefully, when we do not uh, uh, so when we do not shut down gracefully, it might leave some of the resources hanging, right? So yeah, it might cause different kind of leaks. So it's always better to shut down very gracefully. And there are different tricks to make our app uh, quick, or let's say very quick to start up. So that could be one of the trick could be fetch all the dependencies in the build time, and only just spin up the application when we run it, and not fetch any dependencies at that time. So that could be one trick. Other could be to uh, warm up any cache that we need to by delegating that to either a backing service, or maybe sometime after it gets uh, up and running. So not during the startup time. So that there are other as well. So, but we need to make sure our app are like fast, and it will be easier for us. So backing service. We need to treat backing services as bound resources. So first off, what is a backing service? So backing service is anything, as you can see in the diagram there, like different database, the caching system, the object storage, any kind of application service that helps us to achieve some kind of functionality. So all the resources, or let's say all the services that are required for our app to function properly. So all those are considered app backing service. So if there are um, so if our app is responsible to make sure all the user data are saved properly, we need to make sure that the database is up and running. And how should we treat those backing services, and what do you mean by bound resource, right? So bound resource is really just uh, the URL connection string URLs that is needed to connect to those resources, or maybe any other tokens, or so anything that's needed to connect to those backing service could be considered as a bound resource. So when we externalize these configuration, and only declare that our and only declare that the services that we need are these, and we'll be taking and we expect these bound resource in these environment variables, then what it allows us to do is like swap different backing services in the runtime, and without changing any code, or without redeploying our application at all. And the backing service will be able to be swapped around on like when needed. Uh, so so one other pattern that we could use in this is that so after we have declarative approach and like external configuration, like externalize all the configuration, so we could like implement a circuit breaker pattern as well. And what that pattern tells us is that, so if our banking services are overloaded or not functioning properly, we should not, or we will not be sending any requests to those banking services, and not overload them with additional requests until and unless they are responsive enough to like function and provide services to what we need, right? So if those banking services are not functioning properly even after a certain period of time, then some ops people could come and spin up a new resource that's required and then swap out that non-functioning with the functioning one. So it provides us with a greater flexibility and builds more robust application. So the next one is the environment parity. So we need to keep our environment as similar as possible. So when we say environment, we can assume that we have a dev environment, a QA environment, a production staging environment, and a prod environment. Most of the app will obviously have a prod environment and a dev environment. So let's only talk about those two. So the lesser the gap between the differences that we have in dev and prod, the more confident we are in saying that if it works in dev, it will work in production. So there are different factors that we need to consider to make sure that our environments are as similar as possible. So it's very difficult to make it the same because it might be costly, but we need to make sure that the gap is as small as possible. So one factor is time gap. So time gap is when we deploy our application, like only once a month or once every 3 months, once every quarter. So that's a signal that our prod environment and our dev environment are have very huge gap. And the problem behind that would be so when we deploy, if there are any issues, this it would be very difficult for us to like debug where the issue came from, compared to if we deploy like every day. Only a few commits get deployed, then we know exactly what was the reason behind the issue. So other could be other good reasons could be like if we're deploying only like once a month or once a quarter, then it's very easy to forget what code we have written. And that's a very major problem if we forget what the code is supposed to do. And on top of that, if we do not have proper documentation, and if the readability is not as good, so that brings a huge problem, right? So we need to always aim for like continuous delivery. And even if it's not continuous delivery, we need to aim moving towards that, maybe by setting up the CI/CD pipeline and make sure that all the tests pass. So there are different tricks. And other is the personal gap. So personal gap, it talks more about different handoffs that take place. For example, if there is a gap between the person who wrote the code for a particular functionality is different from who deploys it, then there can be collaboration issues with the developer and the DevOps person, right? So that is why DevOps should be a culture, and this is what it tells. The person who writes the code should be responsible to deploy it into the production and monitor its health, and make sure to collect feedback and improve as necessary. So one way to enhance one way to like reduce this gap is to make sure we have DevOps as a culture. And the next one is tools gap. So the tools gap would be like we have MySQL version 8 in development server, and but we have not like upgraded our database in production, and it's still in MySQL 5. So the queries that we have written in dev server and it works there, but when we deploy that to production and if we do not upgrade the database, it's most likely to get like failed, and there are going to be issues. So when we have like different versions and different tools that we use in different environments, then it's gonna introduce a lot of problem and like make our lives difficult. So the rule of thumb is that we try to minimize the gap, and the lesser the gap, the lesser the so wider the gap that we have, or more differences between environment, the lesser the predictability and lesser is the reliability of our application. So moving on to the next one, it's administrative processes. So we need to run our administration tasks, admin tasks and management tasks as one of process. So there are different admin processes. Tasks could be like running migrations, or like running a batch job that is timed. For example, like sending email to our clients every 8 a.m. in the morning and not in Saturday and Sundays. So that could be administrative task, or some of the programming language provides like REPLs, and someone might like go into the server and want to run some like different tasks there. So if we decide to run such admin tasks, then we need to make sure that we run such tasks in a different process, so that it does not affect the performance of our long running application. For example, the running batch processes should not impact the latency of our API request and response cycle. So that's one. And when we run our administrative tasks, we need to make sure that it is run in the identical environment and in the same release and against the same code base and config. So we need to make sure of this, because when we are running tasks, if they have like different environment and different we are working on different release, the behavior could be different, and the results or the side effects could be something that is not anticipated at all. And so in order to prevent any synchronization issues, we need to make sure all those administrative tasks are like shipped into the same code base. So we can also I would suggest to like change the architecture of such administrative processes if possible. For example, instead of having like cron job running in EC2 instances like every 12 hours, why not like change it into a API service, into a service that consumes an API, and making sure it is idempotent, and trigger the event or an API request using CloudWatch or any other tools. So that would make sure that even if the platform scales, even if our app scales for like from one server to 100 different servers, we do not have repeated tasks running like at the same time that consumes cost, resources. So moving on, we have port binding, and the principle states that we need to export our services via port binding, and this is similar to what we stated earlier. So we need to externalize we need to first make sure that our services are services bind to a port, and that port is externalized. So what that helps us to do is make sure that what that helps us to do is one app could be a backing service for a different app. For example, if I'm building a core app, I'm writing different functionalities. If I need to send a notification, maybe like in terms of an email or like a push notification, I would be able to call the notification service that's in the same environment. So this is if we externalize such ports that our service is running on, then it provides a lot of flexibility around there. Moving on, we have the next principle, that is stateless processes. What stateless process says is that we need to execute the app as one or more stateless processes, and having a stated process is very crucial for us to able to be scale horizontally. For example, if we have an API request that stores some kind of state in memory of the server, and if the second API request expect that state to be there to function it properly, then that is not a stated process. We should not be doing anything as such. But if we need to share the state, if we need to maintain a state, then we need to use some kind of backing service like a database or Redis cache, and maintain the state there. And we should always try to like share nothing between the process, and avoid tightly copying different processes. So this is helpful because this helps to like concurrently scale our so this helps to like this helps us in horizontal scaling. So this is the next point, and it says that scaling out via process model. So if different processes are dependent on each other, then um, we'll be dealing with something that's not necessary for, or that does not add any value. So if we keep our services stateless, what we can like reap the benefit of horizontal scaling that our cloud services provide. And being able to scale from 1 to 100 in mere minutes is very big flexibility and provides a very um, great power, and that's very good for business. So we need to make sure our apps are disposable. So all the guiding principle that we just discussed also helps us to achieve the concurrency. And yeah, let's move on to the next one. So telemetry. So first, and what telemetry says is that so it's like automatic recording and transmission of data from remote servers for monitoring and analysis. So uh, we can take an example of like we need insights of how our system is performing, how our app is performing in the cloud environment, because uh, it's not right here in our office, right? It's somewhere in US, it might be somewhere in Mumbai, or somewhere all around the globe, we don't know. So we need to treat our apps like space props and make sure we know exactly what's happening in the remote environment. So uh, so we need to like have telemetry in place. So like cloud service provider helps us to like provides with us with different tools that helps us with this. So for example, cloud was provide us with different services where we can monitor the memory or the disk space, or the number of API requests made. So they are provided by the cloud services, and if we need anything, any other metrics, then we can maybe create our own or use some other third-party tools. So it helps us to like have an insight on our app's performance, and also like monitor the bugs and issues, and it's kind of like a feedback from our app, so that we can make our app better. And there are other tools that helps us to like monitor our backend services like AWS X-Ray or Instana, and also Sentry. So there are various tools that helps us with this. And the last point is the authentication and authorization. So the security should never be an afterthought. So it should be there from the day one. An example could be we need to secure all our endpoints, all our API endpoints using role-based access control. So these days we have like authentication as service, for example, like Auth0, or maybe implement something of our own, like tools like OAuth2 or OpenID Connect, and these kind of things should be integral part of our app from day one, so that so that like DevOps being as a culture, security should also be there into our culture, so that whenever we are discussing a feature, whenever we are planning things, these kind of things are like there in the core of the app, in the philosophy of when we are building the application, so that we make sure we are like cloud apps are as secure as possible. So this is just like following of philosophy. So these are the extended 12-factor app to build cloud native applications that helps us to guide that acts as a guidelines or principles to make sure that we are in the right track, and we are able to reap all the benefits that cloud services provides us, and also make sure that our app could be deployed in any kind of cloud service provider. It also makes sure it also helps us to make sure that our app is portable to some extent and is self-contained. And so a few of the principles also discusses about the divergence of different environments and the issues, and prevents us from having to deal with the issues that could have been just resolved by following just simple principles, and ensure that security is built into the philosophy of building the core application. So these are just the guidelines, and it may not be sure that we follow everything. There might be apps that were already there, way before we joined the team or the project or the company. But when working, or when moving towards being cloud native, or when trying to make our apps better, we need to keep these principles in mind, so that we have less problems to deal with. So with that, I would like to conclude my talk, and thank you for listening to me. So if there are any questions, let's open the floor.
Awesome. Thank you, Curious Sugam. All
You're
right. So if anybody in the audience has any questions, please go ahead and drop them in the chat. I do have a few questions for you, Sugam, that I would like to place. Starting off with why and what you should do to follow beyond the 12-factor app.
So it's a guiding principle, so it should be there on top of your mind whenever you are making any decision. So whenever there is a feature that we most of the teams, I believe, would follow agile, right? So some kind of
Mhm.
scrum kind of thing. So whenever we are planning things, we need to make sure that these principles are on top of our mind, and they will ultimately help us to make decisions, because every project is different and there are no rights and wrongs. There are certain trade-offs that we need to make, and sometimes there are some constraints that we need to have make trade-offs from. So it's all about a mindset or a philosophy that we need to have, and it will guide us to make a right decision. So uh, all we have to do is just be aware that these are the things that we need to follow, and I believe it will take you to the right direction.
Okay. So is it a pick and choose kind of a situation where you have to follow all 12, or you can pick and choose what you like?
So it's not like we need to follow all 12. Sometimes
Mhm.
there are cases when for example, let me give you an example. Um, so let's say there is a very sensitive application, and continuously deploying to that environment, and if there are any issues that could be very catastrophic, then we may not be able to achieve continuous delivery. So that's the trade-off that we need to make based on the domain or the context that we are doing there. For example, if that is something related to life and death of a person, that's not something that we can like take simply. So that's one example. Other examples could be, we are just trying to build an MVP. We are in a very low budget constraint, and we may not be able to like uh, per, purchase different services or backing services. So we go as we think it is good. So that, but we need to make sure that when we do such trade-offs, and we need to make sure that we communicate those things to our clients or any other
Mhm.
stakeholders, that the trade-offs that we have made. And I believe that
Is a good
uh,
rule of thumb.
yeah. So it's not like we have to choose all or nothing kind of situation.
Fair enough. There's a question from Raj who asks, is this talk an elaboration of the Beyond the 12-Factor app by O'Reilly?
Yes. So when I was working on building cloud native applications, so not following these principles led us to the same trap that the book says. And after I read the book, that it was there was many moments that said, oh, I should have read this book earlier. And sharing all the principles that the book shares, I believe would help other people as well.
Awesome. I think it evolves with each person's experience as well. So,
Plus different people come from different backgrounds, and those principles would be taken differently by different people.
completely agree. There's another question by Deepshan who asks, is there any chance that the cloud server gets overwhelmed from fast startup and data within the cloud server gets processed instantly without any consent of the client?
So if we are like not sure about processing our data or not, then I believe we need to have some like manual point where where we say go or no go. So if we are like more concerned about if our data gets processed before our client knows, then that's the context that we are aware of, that the processing would be very swift. And so even before starting that, I think we need to get the consent of the client itself first.
Okay, awesome. I see another question from Robus who asks, in which situation do you think 12 factor plus model won't apply and why?
um there might be cases where it won't apply, and that is especially in like the serverless context, especially in while we are working on lambdas. So there are different factors that do not apply to those contexts. For example, like port binding, lambdas do not have port. So as I said earlier, they should be the guiding principle. But if the principle do not apply, then we need not force them to be applied like anyhow. And other situations could be like it says we need to treat like logs as event streams, and we should not be focusing more around like doing much of an overhead task to uh, deal with logs. But like in large enterprises, sometimes there might be situations where we need to like process logs before we send them out. So that could be another trade-off that we need to make. So I think he's right. 12 factor apps should not be always like considered as they should be there. So sometimes there could be situations where 12 factor app may not be suitable uh, for that particular context.
Okay, awesome. If any of you have any follow-up questions to what Sugam has just said, please feel free to drop them in the chat. We have another question from Yoa Hung. Excuse me if I didn't pronounce that right, but he asks, is there any tools that would help us better manage consistencies of the technologies across all the servers rather than just manual documentations?
So like if we are concerned about all the technologies that we use, and so I believe we are talking about the servers or different cloud services that we are using. uh, I think automating them and using the same automating tool, or let's say same automating configurations like in all the environments would help. And that what that means is using different automating tools like Terraform to build our services, and that would be the same for all the environments. And that will prevent us from like having configurations that are only specific to one particular environment. For example, uh, so if we do things manually, we might have like additional configs around CD, like CloudFront, which will cache something in dev environment. And if that the configuration is not present in QA, it will not be there. So if we try to declaratively write rules and follow such tools like Terraform or like automating tools, then it will prevent us from doing such mistakes.
Okay, awesome. The next question that I have for you here is, how should a cloud native application which follows the 12 factor principles handle its configuration?
So in order to externalize the configuration, like I had mentioned, and in order to handle those configurations, uh, we can use, if we are using the AWS environment, we can use parameter stores or a secrets manager. And what it ensures is that we have those configurations there in the environment when our app gets run. So uh, all we have to do as a app developer, if that is the case, then expect the configurations to be there in the environment itself and not worry about it. And the only way that we can mess that up is to forget adding those configurations in the first place. And I think
Okay.
that also could be automated.
Okay. Um, Anuj Subedi from the audience asks, is it 12 factor apps really an app or something else we are talking about?
Um, So it's a guiding principle which helps us to build a cloud native app. And so with that, what I say is, though these are the guiding principles that will uh, help us build applications that will be able to reap all the benefits or most of the benefits that the cloud services provides.
Okay. Anuj, I hope you got your answer. Poojan asks, is adopting a principles of 12-factor app good for every scale or type of application, or is there any rule to be followed depending on the type or scale of application?
I believe so. Even if we have like a very big applications, um, so if we have like very big applications, then it's most likely that we will at some point like divide them into like different services maybe. So the application should be a manageable thing. So it does not matter how big of an application it is. So these principles may, like most of these principles may apply to them in one way or the other. And but it doesn't have to be like we have to have like all 12 check marks or all 15 check marks to be there to build an application. So it's just a guiding principle. And I believe like no matter the scale, these guiding principles will always lead you to the right direction if applied properly.
Okay, awesome. Next question that I have for you is, what is the significance of the 12-factor apps in cloud native application development?
So in development, so some of the principles also say that even if we have even if we have different kinds of parity that we need to make sure that it's very like feasible or easy to run in like cloud environment. So let me give you an example. If our if our application have like 50 different services, then we need not run all those services in our local machine itself. So we can only run those services that we are building or any functionality for, and like swap out all the rest of the functionalities to either maybe a dev environment uh, or any other services, maybe some kind of like backing services that your office or like team shares. So but to develop in serverless environment like lambdas, it is a little bit tricky there, but I believe it's not very hard, or let's say 12 factor app will not uh, like reduce the like speed of the development or the agility of the development.
Okay, so to build on top of that exact question, how feasible is it to implement all of the 12 factors on an existing cloud native application?
So if we need to like migrate things, when we say migrate, like move the existing cloud native applications to fulfill like most of the uh, guiding principles there. So it's not like one day thing. We cannot just say, okay, we'll take some break for like a few weeks, few months, and then like refactor each and everything. If your business allows that, that's good. But if not, then we need to take one thing at a time, like refactoring things with these factors taken in mind. For example, we cannot say that there are different priorities also that we need to set before like moving on, like moving to follow all these checklists or let's say all these principles. And based on the priority that we set, we can take one thing at a time. For example, if we have every configurations committed to our code base, and we need to that's the urgent priority of our project, to move everything out of there and make it externalized so that we can uh, like set up just any other environment right away. If that's the highest priority, then we should do that one thing first by like deciding on what kind of third-party tools or the cloud provided service to use to externalize this configuration, and then working from there slowly to first do one thing, and then maybe if the next thing that we want to do is like upgrade the version of some sort of backing service and replicate that to different environments, then taking that next. So like one step at a time would should be the right thing to do.
Great. Okay, so we have time for one last question, and this comes from Ajul, who asks, how were you familiar with the 12-factor app principles? Is it the situation you had to deal with, or question mark?
Yes. So when I started working in different like cloud apps, I was not aware about it. Like I said earlier, like while looking for solutions, while looking for, there must be a better way. I think I am doing this, but I think I'm doing this good enough, but I think there should be a better way. So while finding for that solution, I somehow like knew about the 12 factor app, and one of the team member that I worked with earlier shared the additional like beyond 12 factor app with me, and that was like eye opening, or let's say, oh yeah, I should have done this in a few of the places. So like, and after I was aware about it, most of the decisions that I make, at least I have these things on top of my mind. So
So it was
you never know
curiosity.
everything.
Quite apt with your GitHub handle. Okay, so I see a few questions pop in. Let's see if we have time to answer a few. As for planning for production, problem of running in dev and not in production may occur. What do you think should be the focus on dev so that the problem won't occur?
So first thing is to know why it's not working, and in order to know that, we need to have like some kind of insights. So uh, maybe it may be logging or any kind of analytic data, and that is also one of the point, telemetry. So with that inside, we can say why it's not working. And so it's also related to how we debug our applications, but it's a little bit different in cloud environment. So as we go in a distributed environment, it's very important to have insights on how our application works and how they are connected with each other. So first thing would be to have that insight, and then go from there.
Okay. So this seems like just pick and choose type of a question. This comes from Bhavish, who asks, which factor is the easiest and toughest to implement in a project?
Okay, which one is the easiest? I think they are all the same, maybe. Um, because we will have to, like, when we are starting a new project, we will have like all the principles working one way or the other, and we'll have to make decision around that. So one tough thing would be to like have to know what kind of insights do we need to put. And sometimes there might be eh, domain specific metric that we need to place. For example, how many like purchases were made, how many users signed up. So to know what to put in place. So that is a different kind of tough, not technically but conceptually. And so externalizing configurations is also difficult, especially to uh, test and to know what went wrong. So but again, like having a good documentation from the third party services would also help around there. So it's difficult to say which one is the easiest and which one is
So
difficult.
it's a situational thing, circumstantial. Okay. All right. Thank you, Sugam. I think it was fun. It was fun catching up with you after a very long time and hearing your talk about 12 Factor app once again. Thank you, everybody.